All right, so we are still looking at AWK. We're going to continue to do AWK today, and we will most likely be doing AWK again on Tuesday, the next class. And as a reminder, there will be a quiz, but it will be, of course, only up to the stuff that we covered today. Okay, so from the beginning, the stuff we did on AWK, which I believe was not the last class, but the class before. So when you're trying to plan on how to prepare for that quiz, I would advise you to review what we did the last 3 classes, which might mean that you'll want to go back and view these videos that are on YouTube. They're all linked. I linked them on Canvas. If you're taking notes, that would be another way to review. You can also look at the tutorial. The handout that I gave you, also that handout is on Canvas. Some of the stuff that I'm covering, though, is not in the handout, so it's in your interest to make sure that you're aware of everything. Okay, let me see now. So we're going to start off doing a little bit of work. Let's open up a terminal window. And I'm going to make the font bigger. And I think I want to make it a little bit darker in here because it seems like it's a little bit too bright. You guys don't mind. I still don't remember exactly how to make these lights do what I want them to do. Yeah, that's good, right? That one, and then is it this one? I can't remember. I haven't taught in here in a while. Yeah, that'll do it. Okay, so hopefully that'll work, that you'll have enough light to do, write stuff down or whatever else you need to do, but that you'll be able to see the screens a little bit better, okay? All right, I'm going to shrink this down a little bit. And you see that the only thing that I have on my desktop is that file that has employee data in it, because we will be using that again, so I did not delete it. Okay, so let's remind ourselves what's in that file. Okay, so we'll go to the desktop and then cat the file. And there it is. Okay, and so what I'm going to do for now is I'm just going to put it over here. Okay, and then I'm going to open up another terminal window, which you can certainly do. Open up as many of them as you want. Put it over here. Shrink it down. Okay, it's useful to know what the data is while we're doing stuff with it, right? All right. Now, AWK is very flexible, very powerful, and we can use it for lots of things. I'm going to start off with doing a little bit of stuff with some strings. So strings are just sequences of characters, right? Okay, that are linked together into individual, you want to call them a unit or a thing that's dealt with in computing. They're pasted together, basically, okay. So let's do something now. Let me go into desktop, and we're going to use AWK, okay, and we're going to work with this data by putting a command to the command line, an AWK command here, okay, and what we want to do is you're going to type in a variable. We're going to set up a variable called names. So you can set up any variable you want within the function. As soon as you mention it, it will be created, okay? And we had talked about working with numbers and how if we mention something that we're going to use, it's numerical, it will automatically be set equal to 0, okay? What we want here now is something that's going to be a string. So you say, well, let's set it equal to 0. Well, the first time you mention it, it depends on how you mention it. Okay, so if we set it up like this, we can say awk names equals, okay, names, you're finding it, right? Names, oops, if I could type, that'd be good. Okay, and then I'm going to put in the first field because we're going to be looking at this. I beg your pardon? Oh, yeah, I'm sorry. Yes. Thank you. That's missing. Names equal. I had that before and then I removed it. Okay, let me put a space in. I'm supposed to do that. I don't know why I'm having trouble typing it. Okay, names equals names. All right, and then I'm not going to put +1 because this is something that's going to be characters, right? I want to put in a name which is in the first field of this file. We're working with this data, the employee data that's in that file, okay? And then after that, we're going to put a space, okay? So let's just look at that. So what we see here is an equal sign, which means assignment, right? Okay, that the variable names is assigned to have the value of whatever names was before, followed by the first field in the record that we're currently reading, followed by a space. Okay, and so this is how, if you want to paste some stuff together, concatenation is what this is called. This is how you do it. You just list them out. You notice that there are just spaces between these three things. Right? That's all you have to do to link them together. Now, what we would like to do is actually see them. Okay, so what we can do is then say, after you go through all the records, we would like to print whatever names happens to be. Okay, let me just show you what we're doing here. I'm going to make this a little bit bigger. Remember how AWK works. Okay, if you wanted to do stuff, when you set up AWK, you can put, after we start it, which is with this single quote, right, you can put in a pattern. We didn't put a pattern in, okay? We just put in actions within these curly braces here. So that means when you don't put in a pattern, it's going to apply this action to every single record. So what this is going to do is it's going to take the value of names, whatever it happens to be, and then it's going to add on the end of it the first record over here, okay? The first field over here in a record. So in this case it would be Beth when you start off, and then it will put a space. Names, when we have first mentioned it, doesn't have a particular value. If we were setting it up as a number, it would be initialized as 0. Since we're setting it up to be a character string, it will just be an empty string to start off. Okay, so what we're saying is whatever names is, paste this onto the end of it. Okay, and then when you're all done, when you've done that, run through all the records. At the end, we want to print out what those names are. Okay, so we close out with a single quote, and then we apply this to the employee data. So do you see what happened? It ran through all 6 records and just kept pasting whatever the first field was onto the end, separated by a space. And at the end, there is this variable called names, and by the time you get to the end, you've gone through all 6 records, you now have this string of all the names. Okay? Any questions on this? No? Okay, hopefully that's straightforward. All right. All right, let's go on. Let's say we would like to do something else with this. I'm not sure whether we've done anything like this before, but I want to emphasize that we're working with end. Okay, sometimes with AWK, that's all you want to do is something that would happen after you've read through all the records. Okay, where you say, okay, what's the point of that? Well, sometimes AWK is a very convenient way to do things with files. Okay, where it's kind of odd that we would set up an AWK command that doesn't have something that we do to every single line, but that's okay. We can just set up the AWK command and say, okay, after you've cycled through all the records, this is what we're going to do. At the end, okay, we're just going to print out, bless you, a line, okay? That $0, see what happens. Okay, so $0 is something that's reset as you go through the records. It is the record, okay? And so the record that you're working with, the current record. So when you get all the way through the file, $0 is then equal to the last record. So if you want to just print the last line of a file, or the last record, this is the way you do it, okay? Alrighty. We'd like to, AWK also has access to what are known as built-in functions, which are pretty nice, and I just want to show you one of them. When you're working with functions, one of the ones that we've worked with already is printf, okay? when you're working with functions, they are formatted a little bit differently. There are several of them that are available to you. Let's look at one of them that's called length. Okay, so let's say we're going to come in here and we want to print the first field. Okay, and then we'd like to print length. Okay, and then you have to provide an argument. It's a function. It takes an argument. It takes one argument, and the thing we're going to provide it is the first field. Okay? Okay, so this is what we're going to do. This is going to be executed on every single line because there is no pattern that's provided before the action. The action is to print field 1 and the length of field 1 for each record. So we expect to see 6 lines, and there they are. Okay, so you see what happens. Length, it's the length of whatever the object is. So the number of characters, right? So Beth has 4 letters in it, 4 characters, there you go, okay? And so on. So length is kind of handy, something else that's good to know about. And that's just an example of a function that's built into AWK. I just want to draw your attention to something in the notes that are provided to you. Okay, the PDF of the notes that's on Canvas in Chapter 5, the one about AWK. Table 5.3 has a list of built-in functions for AWK. We'll be looking at more of them probably at the next class. Okay, yes?
Why do you not use end for that command there at the end of that string? But you did for the first one.
Why did I not? You mean like this one?
Yeah.
Because I wanted it to print the output for every single record. So you see how I got 6 lines here? There are 6 lines for the input file. At the end of each, I wanted this command, this action, to be performed on every single line that was in emp.dat. In the previous one, here, I only wanted to print the last line. So that's why I did this at the end. Does that make sense? Okay, so you have to think about what is it I want to see? What is it I'm trying to accomplish? So this, you have the opportunity to do things to every single record. You have the opportunity to do something at the end after you've processed all the records. You have the opportunity to do something at the beginning using begin. Does that make sense? Okay, we're going to look at a few more examples so you'll get an idea of the variety of things that you can do doing this, okay? Because you can do a lot more structured programming with AWK, certainly a lot more than you can with SED. SED is very powerful, but it's limited as to what it can do. All right, so here's another example. Let's say, I'll clear this now, okay? Clear, let's go like that. Okay, so here we're going to go. This time we're going to work with AWK again, again on the command line. At some point we're going to need to move probably to working within a file because the commands are getting more and more complex. But I want you to be comfortable with both, okay? We're still working command line pretty much exclusively right now. Okay, so here we are. I've just opened this up, and I'm going to put in some actions that I want to have performed for every single line in the file, every single record, okay? I'm setting up a variable called NC, okay? NC. And that's going to equal, I'm going to be wanting to count the number of lines in the file, the number of words in the file, and the number of characters in the file, okay? So NC is a variable that stands for number of characters. So what I want to do is I would like to set it equal to, like, notice this is the first time I'm mentioning it, right? Whatever it was before plus the length of the line, okay? The line that I'm currently reading, okay? That's what I would like to do. So that's what I'm going to do just for now. We will be going through and doing some other things, okay? And then the number of words is another variable I'm going to set. So I can put in multiple commands within this action portion of the AWK command, right? I can put, but I have to separate them with semicolons. So I do this, and then I say I would like to take the number of words, whatever it was before, and add to it capital NF. Now you may recall, I'll put in some, I don't want to put in extra spaces because there's too much We're going to have to make this kind of compact. I better put spaces in, sorry. I just worry that I'm going to run out of room. This is all going to wrap around, right? So it's going to end up taking up a lot of space, but oh well, here we go. NF, okay? So this is the number of fields. So I'm counting the number of words here, and I'm assuming that the field separator is going to catch each one of them, okay? That's what I mean by a word. It's things that are within fields, okay? And then that's all I'm going to do for now, okay? So I guess I'm going to take that semicolon out, go like that, okay? So I'm counting these things. So as I go through the records, I'm counting the number of characters. I'm counting the number of words, okay? At the end, now I type end. Okay, at the end, I want to do some stuff. Okay, so now I open up the curly bracket and say, this is what I want to do. I want to print the number of records. That's going to tell me how many lines I have. Okay, I want to print the number of words, and I want to print the number of characters. Okay, so I put commas between them. Those are the things that I want to print. Okay, then I close the whole thing out with a semicolon, with a single quote, okay? And then I'm going to start typing EMP, and I can hit tab complete, and it actually completes for me, which shows me that my syntax seems to be valid, okay? All right, so this is based on the file that I have over here. If your file is slightly different, you may see other things. So what got printed first? NR, that's the number of records, which corresponds to the number of lines. Why? Because the default record separator is a new line character. You can make it something else, but we didn't do that. So typically, number of records is however many lines you have in the file that you're working with. Okay, number of words. Okay, then I look here and I say, are there really 20 words? Well, I know that I have 3 fields on each line, and I have 6 lines. That gives me 18. But then on the Dan line and the Mark line, I have 2 extra fields. That gives me 20. Okay, so that seems to work. And then I have 83 characters. Okay, so if I count up the characters, I have to include the blanks. Okay, 1, 2, 3, 4. I don't know how many there are. 5. I should probably change this because it's got too many blanks in it. I don't even know how many I have. Okay, I'm going to go into the file then and make sure that I can count these things properly. So I'm going to modify this a little bit. Let me go in here. Go back to this one and modify this. There we go. All right, I'm going to take this and take out some of this white space because I really want to only have blanks in here. So it's a lot easier to count if I do. Oh, there we go. This one up here. Okay. I can't tell whether I have tabs in here or not. A tab would be a single character, right? And I can't see it. So put this in here like that. I think that's pretty good. Okay. All right, let me just save this. Okay, and then I'm going to kill that. There we go. Okay, so I'm going to run this again. All right, now it says I have 75 characters. All right, that's fine. Now, the thing is, when we're doing this, we really do want to include the invisible character at the end that is the record separator, the new line character. So that means that we should go back to this function that we ran. And here, the number of characters, it's not just the length of what's printed. Okay, we also want to add in 1 for each line, and that will help us to include the new line character that comes at the end. Okay. Of course, that is going to change the number of characters that we have in the file, but this is an accurate listing of how many characters we have in the file, even though we can't see the ones that are at the ends of the line. We do not want to forget about them at all. Okay. All right. Now, a couple more things that we want to do here. One is the way that these things are written. Okay, how we take the number of characters and we take the value of it and then add things to it. There is a more efficient way to do that. We can put in, instead of the plus sign here, like this, the equals plus, we can put in plus equals. Okay, and the plus equals, if you do something like this, if we have NC equals NC plus length, okay, $0, this is what we had, right, basically this, okay, we can replace this with NC equals, not equals, it's plus equals, and then just length, $0. Okay, so it means that we take this piece here, right, and rewrite it. It's actually this stuff here gets rewritten as this. Yeah, not this so much, okay? So this is just, it's to make the code a little bit more compact. It's a very common thing to take a variable and change its value, reassign a value by adding something to it or subtracting something from it. And that's a compact way to indicate that you're changing it. Say, take the current value and then do this to it to make the new value, right? And we can do a similar thing here to the number of words. Okay, we can change this so that now we have plus equals. Okay, and all this means is take NW, number of words, and add NF to it, whatever that value is. Okay, so let's see if we still get the same value. We get the same thing, which is good. Okay, we want to make sure that it's correct. So that's a compact formatting thing, okay, that's very, very common to use. You want to be able to recognize it when you see it and use it yourself. All right, now the other thing is that the print statement is pretty terse. It does list out the variables that we're interested in, but it just lists them as numbers with no context or further information. So let's add some information here. Okay, so let's go back here into the print statement. I'm just going to use print, okay? And then after NR, okay, that's the number of records, right? In this case, it's the number of lines. So I want to indicate that by putting in lines, okay, comma, okay? And then after number of words, I want to put in words, okay? Notice I'm separating all these things with commas, okay? And then after NC, characters, like that, okay? It's just adding some words to make it a little bit easier to read. Okay, 6 lines, 20 words, 81 characters. But it still could be improved, so this is what I'm going to do. I'm going to put in commas. You notice I didn't add them till now because, you know, commas can mean a variety of things. I want the comma to be within the double quotes though, right, to make it just easier to read. So after the word lines, I stick a comma. After the word words, I stick a comma. You see it's still within the double quotes though, right? And then after characters, I'm going to put a period. And then it's just easier to read, okay? Now we could have done all this at once in one go, but I think an iterative process is good. It cuts down on errors, so that's what I recommend usually. You can just get the basic thing to run and then just say, okay, now I need to make it look better. I need to change this a little bit, and that way if you make a change and now it doesn't work, you say, well, I just made this small change, so I'm going to go back to the previous version that did work and then try to figure out what my error is. It's a lot easier than trying to find, you know, the 5 errors that you made in the very complicated thing. Okay. All right. Do you guys have any questions on any of this stuff? I think this is pretty straightforward. All right. So now we're going to go on and talk about control flow statements that you would see in structured programming. So up till now, we've done a lot of text manipulation. It's been sort of like a little piece here, you know, with sed and then with awk. And now we want to take advantage of the computing power of awk, where you can actually embed more complicated structures within the awk program, and that makes it a lot easier to do stuff. It's a very powerful thing, so we're going to start looking at those. And these are probably going to be familiar to you. I know that most of you took ENR 200 last semester, and so you're gonna recognize some of the structures. Okay, they're very similar. So let's look at what are known as if-else statements. Okay, so the if-else statement Just to refresh your memory, if you don't remember, you know, if, and then you have condition. Okay, you notice it's in parentheses. Then do stuff. Okay? Do stuff. And put it in curly braces. All right? Now, that can be all you need to put. Okay, so it's only going to do the stuff if the condition is true, right? If the condition is not true, then it won't do it. It'll just go on to do whatever you put after that. There is the possibility of this, else. Okay, do other stuff. You don't have to have an else statement in there, but you could. And in which case, if the condition is true, you'll do this. If the condition is not true, you'll do that instead. Okay? If, else, I think these things are familiar to you, right? Okay, so let's look at how we can use that. Remember we did something with reading the pay of different people. Let's go back to this, the employee file, and how we could figure out the total amount paid to all of the employees that are listed in a particular data file, employee file, and we could also figure out what the average pay was. You remember that? Okay, let's use that to help us. I'm going to do clear now to do the next thing that we want to do. Okay, so let's say that what we would like to do is find the employees that are paid at least $20 an hour. Okay, so we can do it like this from this file. Okay, AWK, and then we're going to say what we want to look at is the second field, because that gives the pay, right? And we say the test or the pattern that we're seeking, because remember we can do that, right, is if field 2 is at least 20. Okay, if field 2 is at least 20, we want to count that person, okay, as somebody who is making at least $20 an hour. That's what we're using a variable n to just count out how many people there are in that situation, okay? And so I'm mentioning n for the first time, and I'm saying increase it by 1. Okay, so the fact that I put in n++, what awk does is it says, okay, I need to create this variable called n. I'm going to initialize its value at 0. Oh, but I have to increment it right away. Okay, so the first time I find one of these, it's going to set it equal to 1. Okay, if it finds one, all right? So that's the first thing that's going to happen. And then I need to take another variable that I'm going to set up that's called pay, okay? Pay, I'm going to say whatever value it was, I'm going to increment it by what field 2 is times field 3. Okay, field 2 times field 3. So let me just, I need to make this kind of, I want to make that one wide, I want to make this one smaller, make this smaller. Okay, it's not showing the whole thing though. Ah, okay, let's look at that now. Move it up a little bit. And then this one, I'm going to bring it down, I'm going to make it wider. No, I'm not. There we go, like that. Okay, that's better. At least I can make it really wide. Okay. So you see, we have two variables now, n and pay. Okay, and now once we have these set up, it's going to go through the file, find all the employees that make at least $20 an hour, count how many there are, add up all their pay. Okay, and then at the end, after that's all done, the next thing we're going to do is say print n. Okay, and then after that, high pay employees, total pay is pay. Okay, then comma, average pay is pay, whoops, pay divided by n. Okay. So I want to apply this script to this data, the employee data that we have. Okay, so what it's supposed to do is find everybody who makes at least $20 an hour. okay? And then just take all the hours that they work, the pay that they get, add it all up, find out the average pay, okay, for those people. So there are 3 people in this file that make at least $20 an hour. Okay, so we're all set now. All right, now let's see what happens if instead of finding the people who make at least $20 an hour, we find the people that make at least $30 an hour. What happens?
Oh, we don't have anyone who's paid higher than 30.
So what happened?
So error.
I'm sorry?
Error.
Error. Why was there an error?
I didn't get an error.
You didn't get an error? How did
It
you not
just
get an error?
blank. It just, since it didn't know what it was referencing, it just left it blank.
Did you type what I typed here? Did I?
Yep.
I don't think that's possible. I'm sorry, because did you put in exactly what's here? Because what is the problem? What is the problem here?
They're not initialized. There's nothing. Since the initial condition is not true ever, therefore none of the variables get initialized. Therefore, it doesn't know where to pull.
No, it always, what awk does is it does assign an initial value to it. Yeah, that's the problem. Like if it, so when you, the first time you mention n and you say increment, you know, then that's an indication to awk that this is a number. So it's going to assign it the value 0. Okay, and then if you go through all the records and there never is an employee that fits the pattern, then you're never going to increment n. It's always going to be 0. At the end of when you go to the end part of this awk script, it's going to be 0, and everything's going to be fine until you get to this. Okay?
My computer at the end, its average pay is -nan. This is
Okay.
not a number.
Is that what you guys?
We all got.
You all got that?
Yeah.
Huh? Why would that be?
Would that be not a number? Maybe?
I guess so, but I'm just kind of mystified. And you say you typed exactly what I have here.
Yep. I have the pay divided by n. Newer version question mark?
Okay, yeah, I don't know. That strikes me as strange. I don't know how that could be.
You're using mock?
I'm not. I'm just using awk. Do you think I did install gawk? Do you think that's why?
Yeah, you're using gawk, they're using mock.
Okay. Why am I using gawk?
I
Okay. Is it because I have gawk? That's the reason?
Yeah, it's
okay.
you installed it,
All right.
so it's superseded.
Okay, well, at any rate, it doesn't work, right? It doesn't work. Okay, so we have to fix this, and so let's talk about how we're going to fix it, okay?
Yeah, they all error out. It's just a different
They all error out in a different way? Okay, all right. Sorry about that, guys. Yeah, in anticipation of another activity that we're going to do, I installed gawk to get certain files, and then Dylan did warn me that this might happen, that there might be certain functions that didn't behave exactly the same way. No, he's just the messenger. Don't shoot the messenger, okay? It's so it's good that you tell me when when your thing doesn't do what my thing does, okay? But I'm a little dismayed. I may have to uninstall gawk. I'm not happy. Yeah, I'm not happy about this. But at any rate, we need to fix this. So this is the point of doing this is not that we don't have matching errors. You guys have an error too. It didn't work, okay, right? And it's because of this division by zeros. So what we need to do is take advantage of some of the data structures that we have access to make it so it's not going to be a problem anymore. Okay. So what we can do to do that is we can put in. Let's see how we're going to do this. I got to make sure I do this correctly. Okay. Okay, let's go back to this, and we have to put this into the end part. Okay, so it's no problem. The main part of this, where we're just counting up the pay and all that, that's fine. It's when we get to the end that we need to do something a little different. Okay, so within this curly brace is the stuff that we do at the end. If n is greater than 0, okay, meaning that we actually found somebody who makes at least $30 an hour, right? Then I put in another curly brace, okay? And then I can print all this stuff out. And then when I get here, I got to take out this quote because I have more to put in. Else, print, there are no highly, paid employees. Okay, close out the quote.
Oh, you have the bracket.
Uh,
But it ended if.
At the end of
Yeah,
if,
that should be there, because
yeah,
there's the bracket to start the if.
yeah, I put a bracket in to start the if, and no, this is all the stuff that we're doing with,
There's one bracket to close this bracket, and then later at the end of the files, you'll put in another bracket to close.
The whole thing.
This bracket.
like that, two at the end right
Yeah.
there? Yeah, that's what I figured, and then this, okay. So what's going on here? What we have here is, I have if condition, but see, here's the thing. You got end, okay? And when you do end, you say, when I get to the end, do all the stuff inside the curly brackets. So you start off here, and then there's another one right here at the end. Okay, now it so happens that the stuff we want to do inside the curly brackets is an if statement, okay? So I say, okay, if condition, and then here's what we want to do if the condition is true. Print n, all this stuff, high pay, total pay, blah, 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 up to here, okay? So this is the curly brackets for the if. Else, do this, and all the stuff we want to do with the else is here. Print, there are no highly paid employees. Curly bracket. Okay? Okay, so that worked. I hope yours worked as well. But this allows us to take advantage of situations where, you know, there might be something that doesn't work properly if we don't have what we need, right? Otherwise, you can only use certain data files, right? If you can't, you have to be able to anticipate what kind of data you have. This gives you more flexibility. Okay, so that's the if-else statement. I think I would like to show you how this would look inside a file, because things are getting more complicated at this point, and so I will open FeatherPad and we can put the function inside, and then I show you how it would be formatted, how it would be a little bit different from how we're doing things here on the command line. So let's see, I'm going to open FeatherPad down here, FeatherPad, ampersand. Okay, there it is. Sorry, I'm blocking this now, though, and I'm not happy. Let me see if I can resize this where you can still see everything. It will wrap around, but you should be able to see what you're doing here. Okay, let me put the FeatherPad up here. I'll make it a little bit narrower. Okay, so inside FeatherPad, what we can do is we can put all of this stuff in here, but we're going to need to format it a little bit differently. So I can take all of this, and I can, no, it's not doing what I wanted. How do I get that? Copy. Okay, and then I can paste it in here, I think. Paste. Yeah, okay, so I just took this command and stuck it in here. Okay, this is the stuff that I had before. The first thing I'm going to take out are the quotes. I don't need those anymore, right? The next thing I'm going to do is I'm going to put the end on its own line here, okay? And then I'm going to put the if on the next line. Okay. So you see what I did? I took the whole thing and I'm trying to format it in a way where it's a little bit easier to see what's going on. This is not doing what I wanted. Total pay is okay. Yep, here we go. All right, I'm gonna save this. I'm gonna call it, I'm gonna go into my desktop. I'm gonna call it pay.awk. Where is it? It's on my desktop. I'm not sure that it is. Yeah, there, now it's on my desktop. Okay. Now to execute this file, this awk script, that's all right, I can open it again. File open, it's actually on my desktop. There it is. Kill off the other guy. Okay, here we go. In order to actually execute this, I will do awk, and then I say get the file pay.awk. That has the command in it that I want, the various commands, right? And apply it to emp.dat. Okay, and it worked. Now we are going to continue to use the command line because I want you to be very comfortable using a command line, but it is more difficult to see what's going on when the commands get more complex. So I may be pulling up and putting things inside the script, inside a file for you to look at a little bit more. All right, so you see what's going on here, right? You have, as awk does, you have a pattern followed by action. So the stuff that's in the first line is applied to every record of the file, okay? At the end, you have this stuff that's done, okay? All this stuff here that's in the curly braces. Now, one thing I want to just show you is, you see how I have this curly brace here right after the end? You say, what's that curly brace doing there? Well, if I try putting it on the next line and I save this, and then I try to execute this again, I get an error. Okay, so that curly brace has to go on the same line as the end, because the idea is when you actually put in the word end, you're saying at the end I want to do stuff. So if you don't have the curly brace on the same line, it's interpreted by awk to mean like, well, you're not going to do anything. Even though it's on the next line, it doesn't seem to matter. Okay, you have to put the curly brace there. All right. So I did that for these other lines too, for the same sort of reason, just to make sure that everything is formatted as it should be. Okay. All right. Okay, so that's if then. Okay, so let's go on now and let's look at loops. Okay, so there are a couple of loops. So the if then is just you do this or you don't do this, and then you move on to the next thing. Okay, but let's say that we would like to print out the squares of numbers. Okay, like let's say we want to start with 1 and then go all the way up to 6. Like print out the squares of numbers, 1 for each line of this file. Okay, we want to do it 6 times because there's 6 lines or 6 records in this file. Okay, so let's look at this. We're going to do awk, open quote, and then we're going to do begin. Okay, begin. And we're going to, the first thing we're going to do is put in a curly brace, because you say at the beginning, before we process any records, this is what we would like to do. Okay, we would like to say that I is equal to 1. Okay, we're using I as an index. We're setting a value for I. It's the first time we mention it, so it's going to be initialized to be I. Okay, and then I think this has to go inside the begin structure, so I'll have to put in a semicolon. While a condition is true. So the condition, as was true for the if statement, you put the condition in parentheses. So here, the condition is going to be I is less than or equal to 6. Okay? And while that's true, what we want to do is print I squared. So we can just put I times I. Okay? So we want to change this though. So while I is less than or equal to 6, we want to print what I squared is, but then we also want to make sure that we increase the value of I. So we can do that by putting in I plus plus. Okay, then we put in a semicolon and another semicolon. I hope that this is going to work. I think this will work. I'm not sure that it will. Okay, but let me put in emp.dat here. It might not work. Oh, it did work. Okay, good. Okay, so this one is a little bit odd because you say, what's going on here? Why was it that this is all happened at the beginning? You know, it just seems a little strange, right? This is an instance where, you know, it's almost like it didn't even matter what file we applied this to. The fact of the matter is that we said that we wanted I squared to be printed, right? And we put in this while loop, meaning while the condition is true, while I is less than 6, print out what I squared is, okay? You initialize it, and then after that you have the while loop structure, okay? It's crucial that we have in the I++ here, because if we don't have the I++, then it's never going to get to 6 and stop. Okay, it'll just keep going forever, right? So if you take it out, like if I take that out, it's never going to stop, right? I should just interrupt it. So this is the correct one, okay? So this is a while loop. There is another kind of loop that is similar. It's called a for loop. Okay, for loop has a slightly different structure. So I'm going to show that to you now. Let me just erase all this because it's going to be very similar. Let's say we want to carry out the same task. Okay, so I'm going to say I equals 1. Whoops, no, I'm not going to. Yes, no, I'm not going to do that. We don't have to initialize it. That's right. Okay, we just start things off. At the beginning, we say for. Okay, in the for loop, inside the parentheses, you put 3 things. You put an index and you say what its initial value is, and we're using I, okay? We want to start it off at 1. You put in the test that you undertake, okay, to keep going with the loop, okay? That I has to be less than or equal to 6. And then the last thing you put in is how you're changing your index, the change that you're making, and that is we're going to increase it by 1, okay? It doesn't have to be that. It could be something else. You could be decreasing it. You could be multiplying it by 5. You could do whatever you want, but you're going to be changing your index every time you go through on this for loop. And then once we set that up, then we have the things that we do while the for loop executes, okay? And that is we're going to put in print, and we can put in I squared again, okay? And that's what we're going to do here, okay? And so the actual stuff we got to do goes inside print I star I, and then close off what the begin structure is going to do. Okay, so over here, you see we have begin, and then we have the curly braces, and that everything inside is what you do at the beginning before you go through the records. So it's almost like it doesn't matter what file you apply this to, because it's going to do the same thing. Okay, let's close it off with the close quote and put in emp.dat. Okay, same thing. Now, if we had another file, let's say I took head-2 of emp.dat and I put it into emp2. Put it into emp2.dat. Okay, so now we have, if I cat emp2.dat, I just have the first 2 people, okay? If I go back to this loop, let's say I take the for loop, and instead of applying it to emp.dat, I apply it to emp2.dat. then what I'm going to end up getting is the same output. Because I execute the loop 6 times at the beginning before I actually go through the records. And you'll notice that with awk, right, think about how awk is. When you use awk, you write awk, right, and then you put in the quote, and then you can put in begin, and then you can say do this stuff at the beginning, right? Or that can be omitted. And then after that you can put in pattern, and then you have actions that you can carry out if the pattern is matched to a line in the file, right, a record. And you can keep doing that. You can do it multiple times. You can have a different pattern and say, okay, now do this, and then another pattern, now do this. Okay, and then you can say at the end, if you wish, you can do end, and you can say at the end, do this. So this is the stuff you do when you're reading the records. Reading records one at a time. Okay? So that's the stuff that you do, but before you read the records is the begin structure, which you can put in if you want. And that's what we did in this one. The begin part is where we're squaring those values. Okay, we're squaring those numbers, and it all happens at the beginning. Okay, so that's why I said it didn't matter what file we apply this to, because the begin stuff happens before we read anything. And then after that, there isn't anything else. All the other stuff isn't there. There are no commands like do this to the file, do this at the end. It's all begin stuff, okay? So you can use awk to do that sort of thing. You can do basic computing stuff, and you can pull data in from a file if you wish, or you can just do stuff, okay? You guys have any questions on this? This is a little bit, no. Go for it, okay. All right. Okay. I want to talk to you now about something that I think is going to help you with the data smoothing assignment that you have to do, okay? And that is, we're going to be looking at a file. What we want to do next, we're going to use Featherpad to type this next one. We're going to make up a file, a little awk script. Let me do a new one that is going to print numbers from 1 to 100. Okay, it's going to print numbers from 1 to 100, and it's with the exception as follows, that if a number is divisible by 3, we're going to print out the word fizz, okay? We're going to print out fizz, okay? If it's divisible by 5, we'll print out buzz, okay? If it's divisible by 15, we print out fizz buzz.
I figured out a fix for how to swap back to mock.
Okay, you'll have to tell me about that later, but thank you. Okay, so now in terms of how to do this, if you think, okay, that what that means is we want to go along and say we got 1, 2, and then we want to now put fizz, right? And then we got 4, 5, not 5, it's going to be buzz, right? And then 6, 7, actually divisible by 3, so 6 should be fizz, right? Fizz. Okay, and then so on from there. So this is a situation where we're going to want to use some if statements, okay? So let's start. We're going to do this as a begin thing, okay? Let's start with begin. Now tell me, okay, let's say we set this up as a for loop where we have I is going to represent the number, some number between 1 and 100, okay? So we have for I equals 1. That's where we're going to start with it, okay? That's initializing it, right? And we're going to keep going as long as I is less than or equal to 100. And every time we loop through, we're going to increment the value by 1, okay? So there we go. That's setting it up so that we can go ahead and print these out, right? Now here's the thing. We don't want to just print the number, okay? Generally, we do want to print the number, but there are times when we want to print something else. So we're going to need some if statements, right? If else's. So what should be the first condition that we look for? Should we print
Divisible by
divisible by 3? Okay, so if I is divisible by 3, how do we do that? How do you decide whether something's divisible by 3?
you find it, and if there's no remainder,
Yes.
would you use the percent thing? Equal to-
Yes, that's called the modulo function. That's exactly right. We want to use the modulo function here. Okay, so if I modulo 3, okay, if you give this command, right, and you say it's equal to 0, okay, that means when you divide by 3, the remainder is 0, right? Because that's what modulo returns. It returns the remainder. Okay, then we want to print fizz, right? Okay. Else, right? Now what?
Equals I. Or do we continue with
Would it just be print I?
Would it?
that?
We have other things we want to do, right?
Oh. I percent, or parentheses, I percent 5.
Okay, so we have another condition, right?
Let's do it.
We have to do else if, okay? If, okay? I modulo 5 equals 0, right? Gotta move these. Okay. Print buzz, right? Okay, now what? What?
More else if divisible modulo 15.
By 15. Okay, if it's evenly divisible by 15, meaning that there's no remainder, print fizz buzz. Okay. All right, now, if it doesn't match any of these patterns, what do we do?
Print I.
Just print I, right? So else, otherwise, right? Print I. Okay. Okay.
Shouldn't the 15 be first?
Why?
Because then it would fizz, then it would skip over the 15s because they're all also multiples of 3.
Does everybody see that? Okay, if you test a 15, it's gonna print out fizz for 15, which is not what we want, right? We want to print out fizz buzz. So the ordering is important. We're gonna have to put this statement first, this one. Okay, so if, I'm gonna fix this up, clean it up a little bit. If I modulo 15 is 0, print fizz buzz. Else, if I modulo 3 is 0, print fizz. Okay, so first it tests for divisible by 15, then 3, then 5. Okay, let's see, do we have enough parentheses here? I think so. You can put another,
Yeah, sure, could be that.
I think that we want to put one here
Yeah.
and then here. Okay, that should work. Let's try this out. So I'm going to save this as fizzbuzz .awk. Okay. So to execute fizzbuzz.awk, let's see, I'm gonna, sorry, I have to go ahead and narrow this down. Here we go. Okay. We're gonna have to apply it to a file, which just seems a little weird because there's no reference to any file here, right? You see, we're not even dealing with any records. There's no $0, $1, or anything like that. So we will need to do that though, because if we access it on the command line here, we have to do awk-f and then fizzbuzz.awk, and then we can just give it any file name. Let's do emp.dat, doesn't matter what we use.
Do we even need to put anything down? Because I
Did you try it and it didn't matter?
I don't even need anything.
Okay, let me see if that works. Yeah, you're right. You're right. We didn't need to put anything. Okay, that's good to know. Thank you.
I was thinking just because it's not referencing.
It's not referencing anything. That is correct. It's not reading. So, given that it doesn't reference anything, that you just have begin stuff, you don't have to put the file in. Thank you. All right, let's go back and make sure this is correct. Okay, 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 12. This is 12, 13, 14, 15. Yep, fizz, buzz. Okay. And then let's look at 30 just to make sure. Yep, that one's correct too. Okay. All right, good. All right, so modulo is useful, and as I said, when you're doing your data smoothing, yes, Doyle?
Because we're not dealing with a file, are we just using awk to print stuff out, or why are we using awk?
Yeah, we could use awk to print stuff out. It's just showing the power of awk, really. I mean, sometimes, a lot of times we'd be doing this with a file. I opted to do this particular exercise just to show the control structure. I wanted to show you how you could structure the if-else and multiple if-else's nested ones in the file. That's all. Yeah. But generally, we would want to use it in the context of files. It's just, if I added in stuff about files, then it gets more complicated. I just wanted to focus on this. But in general, we would be, yes. Okay. All right. Okay. I would like to talk to you now a little bit about another topic that this will be the last thing that we do, and this is arrays. Okay. An array is a collection of objects that are related to each other. It's a way you can store related values together. Where you have a collection name, okay? If you name it something, I could call it something like colors. Okay, I could say I have an array of colors, okay? And then I could index these with an index here, okay? Generally speaking, these are numbers, but they need not be. Okay, so you could have a list of colors that you keep in an array where you say, all right, colors, the number one that I have stored in here is red, okay? It has some value, and then I have colors, and in number 2 I put blue, okay? And then in colors 3, I put black, okay? You could just do something like that where you say I have this set of things, there happen to be 3 of them. So you can think of this, it's like a vector, okay? That's a way you can think of it, all right, where you have things stored in a line. You could have something that is, the array could have other dimensions, but we're just going to be dealing with one-dimensional ones. You can use it as follows. Let's say we would like to take some input. Let's say it's, I'll go back to this record here, okay, where we have the employee data again. Yet again, the employee data, all right? Let's say we would want to print it in reverse order, okay? Let me get a new way of doing this. Yeah. Okay, we'll do it here. Let's see. I'm going to do a new thing. I'm going to call it reverse. But let's just start with this. The first thing that I'm going to do here is, without any pattern, but just an action, is I do line, okay, with the record number. Okay, that's its index. I'm going to set it equal to whatever the content of the record is. Okay? That's the first thing I'm going to do. Now you can put comments into an awk script just by using the pound sign, okay? And this is, remember, each input line. Now here's the thing, generally speaking, when you're processing, you have the line while you're processing it, and then you move on to the next line, you don't have it anymore. But this, by saying that I want to store it in an array that's called line, that has an index that is whatever the record number is, okay, that means that I now have captured it. And just by mentioning it here in the code like that, I'm setting it up. I'm initializing. I'm saying, okay, I have this thing. It's an array. I'm just declaring it. Okay. So I have it there. Then the next thing I'm going to do is at the end. So all I'm doing is I'm reading in each line and putting it in the array. Okay. At the end, this is what I want to do. Okay. I want to say I'm using I as an index. It's going to equal whatever the number of records are that I've read. Okay, so if it's a 6-line file, I should equal 6 at this point. Okay? Then the next thing I'm going to do is I'm going to use a while loop. While I is greater than 0. I want to print line I. Remember, it's an array. Okay? So I'm going to start with, say, line 6. Okay? What?
For that while, do you have to...
Oh yeah, I'm missing a thing. Yes, thank you. Messed that up. Thank you. All right, right there. Okay. All right. So then, after we print the line, though, what we're going to want to do the next time we execute the loop is print line 5, right? So we have to take the index and reduce its value by 1, and you do that by I minus minus. Okay, that just drops it down by 1. Okay. Then after we do that, I'm going to close out the while loop, and I'm going to close out the stuff that we do at the end. That's the second set of curly braces. Okay. So this first line here is executed on every single line because there is no pattern that precedes it. So every line does this. It's just captured, put in the array. At the end, we execute this part of the code. Okay. So now I'm going to save this as reverse.awk. Okay. Come over here. I'm going to clear this, and I'm going to say awk-f reverse.awk. Oh, it's not working. Oh, because I need the file, don't I? That's right. Okay. I need the file emp.dat. Okay. So it prints them in reverse order. So we've worked through a bunch of examples, and some of them you probably have now as files, so that you can look at them and review them and have example. I think examples are helpful. You have examples that work, and you know that they're structured in a way that'll work, so if you want to do other things, you'll be able to use them as starting points. Okay? So that's all we're going to do today. I'll see you guys next time.